Hello and welcome back. Today is May 13th, 2020, and we've got a new project to show off. This is the ENPM 673, project number 6, the Convolutional Neural Network. And our task was the Kaggle dog versus cat dataset, in which we built a convolutional neural network, trained it, and then tested it. And we're going to go ahead and show off some of the features. First thing that we're going to do to start off is we want to show off what our CNN is. As right here, you can see that we have a convolution, a ReLU, and a pool. Originally, we were using a second convolution, ReLU, and pool. This was based off of the MNIST data that was previously a project of mine, and you can actually find in the link down below in one of the GitHub links that I leave in the description. We then flatten it, do a linearization, a ReLU again, and a linearization. The reason that we didn't go with a full convolutional neural network is because they can often take a lot more time to train, even though this one did take a lot of time to train, but we were able to get really good results, namely because we bypassed a lot of the convolution and got right to the characterization using the ReLU function. If you want to learn more about the ReLU section, I'm not going to go into that. You can go ahead and give that a quick Google. If you do have any questions, you can put it down below. But what it is a linear activation function for a neural network. And you can use these with convolutional neural networks or other neural networks, including ones that do stock prediction. What these do is they help classify our results as having certain characteristics or not certain characteristics. And the reason that's so powerful is that instead of having a negative output, all negative outputs are made to 0, and all positive outputs are just positive outputs. So as you can see, convolution, ReLU, pool, flatten, linear, ReLU, linear. And that gives us a linear approximation between all of our classes. So let's go ahead and get started. Go ahead and launch our IDE. Now, one important thing is how we actually managed to bring this data set in. For this, we actually need to get our data set in terms of tensor transforms. Now, if you're not familiar with these, they're a specific type of transformation that allows for a lot of data processing. For ours, we do a bunch of randomization, rotation, resizing, horizontal flipping, normalization. Normalization is probably the most important one. You can not have a lot of these other ones, although the resize was important because the bigger the image, the more time it takes to process it. So by doing a 30 by 30 image, we're actually able to cut down on the amount of time that was needed to process our training. So we'll go ahead and show off the folder that this is in, because it's actually pretty important. So as you can see, we have our dogs versus cats folder, we have our tests in our train folder, and we have a subdirectory that contains all the pictures inside the test folder. This is actually how we're getting our labels when we're importing. And we do that with this. Originally, there was just a train folder that was right here, but our program will make it so that all of the cat pictures go in here, and all of the dog pictures go in here. And the labels of our folders, or our subdirectories, are actually our labels for our testing or training. We actually don't have any labels for the testing, and we'll show off how we actually did that. So why don't we go ahead and run it. As always, we have some soft inputs here, so in case you're using a Linux machine or you have a different file structure, you can go ahead and put it in. As you can see here, this is asking for our main folder. The default is set to this, and we're just going to hit enter because I like setting the default so that it's a lot easier to use if you actually structure your file systems the way that we do. And just like that, it's already telling us that our dog and cat folders have been created. And before we go into starting testing this model that we've trained off, we'll go ahead and say that no, we want to train a model. For this, we're actually going to be taking a certain amount of data. This is known as our batch size. For our training data, we take 64 image per epoch. And for our test batch, we actually want to test against the entire data set to see just how well we do. So as you can see here, additionally, we want to shuffle our training data. That way we're not just getting routine results. For the test data, it's not so important. We just want to be able to see, did it guess dog when we have a dog picture, or did it say it was a cat? Once we do that, we set up a learning rate. This is 0.1. Give a number of epochs, which is 128. With these hyperparameters, it took about 9.5 hours. So we're just going to go through a little segment of the training, just so you can see that things are working as intended. Go ahead and hit and there's our hyperparameters again. And this is going to validate. So in neural networks, not just convolutional neural networks, but neural networks in general, there are 3 stages. There's training, validation, and testing. Now these are all very similar fields, and the most important one is actually the training. What training does is it runs a forward operation using our convolutional neural network, and it activates our neurons and adjusts them as necessary. It then calculates how far off we are. This is called our loss. And for this, we actually did a entropy loss. I can show that off. It's right here, cross entropy loss. Once we do that, we then have to optimize or deactivate our neurons. And for that, we use eta delta. You can also use atom, but eta delta does use some additional parameters, and I'm not going to go into why they're different, but they are very similar, and eta delta is typically the better one that you want to go with. Once it's done doing a training session, or several training sessions, depending on how you set up your program. We did it so that after every epoch, it will actually do a validation. Validation only runs the forward operation to see how close we were to our set. And this is basically doing like a mini batch test. As you can see here, we have a loss of 0.017 for our training. And then for the second batch, it's 1.72. But when we did our validation, we could see that our overall loss was 0.69, which isn't too bad to start off with. It means we've got a pretty decent build for our neural network, because anything that's below 1 typically suggests that you've got a decent design. The lower this number is initially, typically the better it is, but there are exceptions. So as you can see, our loss is steadily increasing, and this is going to continue increasing until we hit our second epoch. Because as you can see, this is an aggregate loss for the training data. So we'll go ahead and end it here, otherwise this is going to take a while. And we'll go ahead and go into the code once more. As you can see here, once we finish training our neural network, we give the option to save off our neural network. And this was really important because, like I said, there were models that we were building that would take 9.5 hours to train. So having one neural network train for that long, not save it off, and then not test it how we wanted it to, was going to be devastating. And so the one that we want to show off is actually model 128, 10 by 10, 0.1 LR. The 10 by 10 is actually misnamed because we did end up using a image size of 30, but you can't exactly go in and change this. So let's go ahead and rerun this. Enter, enter, enter. Alright, so now we have the option to load a model. I'm going to show you the training entropy loss and the accuracy of this model that we're actually going to be using. So here's the 128. As you can see, we get approximately an average of about 98%, 96% overall. And we can really compare this to one where we have a 64 epochs, where we only get about 70% accuracy. So that extra 64 epochs really made a difference. Let's go ahead and take a look at the cross entropy loss. So here's our 64 epochs again. We only get to about 4. But with the validation entropy loss, we get down to sub 1%, which is really good. Granted, this is the validation entropy, so you don't see everything. You just see it per epoch trial. And then we have the cross entropy loss per trial. So this is where we're actually doing our training entropy. So you can see we get to 4, and here we actually get really close to 0. I remember when I was training this, we got down to, I think it was around 0.01, which is really good. So now that we've shown that off, let's go ahead and load up our model. As you can see here, default is the model that I want to run. So let's go ahead and just hit enter. And now it's going to test the model. This is going to take a little bit because the testing folder contains, I think it was 125,000 pictures. Let's go ahead and take a look real quick. Oh yeah, look at all those pictures, all those good dogs and cats. There it is, 12,500. And here's our results. So as you're starting to see, for the most part, we're getting really good results. Obviously, not perfect. We got a dog here. This is supposed to be a cat, obviously. Then cat, 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 dog, cat. We're doing really well. Most of these pictures are turning out just how we wanted it to be. I think the only other one that we got right here is this dog that looks a lot like a cat. So once we're done with that, we're given the option to restore the folders. And because I'm actually done doing all the testing and training that I need to do, we're going to go ahead and hit yes. What this is going to do is it's going to restore all of the folders to the initial way that they came into us, in unzipped form, that is. So let's go ahead, take another look at our folder, all the pictures. Looks like it's done doing that. All of them are restored in our directory. Boom, just like that. They're all back in train. And look, it even deleted the rest of the folders as well. So yeah, thanks for watching. I hope you enjoyed this. If you have any questions, just put them down in the comments down below. If you want to check out this project as well as some other ones, feel free to subscribe. Check out the GitHubs in the description down below, and thank you for watching.